Okay, for next question, which is question number 26, we have to state the rule to determine the direction of magnetic field produced around a straight current carrying conductor. So this is part A, and the rule is right hand thumb rule. So this is right hand thumb rule that is used to find the direction of magnetic field produced around a straight current carrying conductor. And it says that if we grasp, so we don't have to actually grasp. If you imagine that if we grasp a straight current carrying conductor in our right hand, so this is a straight current carrying conductor in our right hand, such that thumb points in the direction of the current. Thumb points in the direction of current. Then the direction in which the fingers curl gives the direction of the magnetic field. So this is the right hand thumb rule, and let's say if it's a straight current carrying conductor, and if the current is flowing in this direction, and if you use our right hand thumb rule, so this is our right hand, the thumb is pointing downwards, the fingers in which the fingers curl. So we know that for a straight current carrying conductor, the pattern of magnetic fields about any element, let's say this is the element, it's always concentric circles. So we have to give the direction, whether it's clockwise or anti-clockwise. And if you use a right hand thumb rule, so here the current is in downward direction. So if we like try to grasp the conductor in our right hand, the thumb points in the downward direction, the fingers are curling, they are going for into the page of the paper in this direction. So this is the direction of the magnetic field. So they are going into the paper, into the plane of paper. Okay, so you have to imagine this as the plane of the paper. So make sure you imagine this as the plane of the paper. So let this be the plane of the paper, and then you have to give the direction if it's into the plane of the paper or it's out of the plane of the paper. Okay, so let's move on to the B part. Now, the force experienced by a current carrying straight conductor placed in a magnetic field which is perpendicular to it. What is the rule that we use? And the rule that we use is Fleming's left hand rule. This is Fleming's left hand rule. So now it states that if we stretch, so if we stretch our forefinger and middle finger and thumb of our left hand, and that is mutually perpendicular to each other. Now we have to line our forefinger such that forefinger gives the direction of the magnetic field. So make sure you align the forefinger in the direction of the magnetic field, or you point the forefinger in the direction of the magnetic field. So such that forefinger gives the direction of magnetic field. align your middle finger in the direction of the current so that the forefinger gives the direction of magnetic field, and we can say that and middle finger is aligned or pointing in the direction of middle finger is pointing in the direction of the current. Okay, that is correct. Then because your thumb forefinger and the middle finger are mutually perpendicular, they are stretched mutually perpendicular, then the direction in which the thumb points give the direction in which the thumb points gives the direction of the force acting on a conductor, gives the direction of force or the motion of the conductor. Direction of force acting on the conductor or the motion of the conductor gives the direction of force or the motion of the current carrying conductor. So this is the Fleming's left hand rule. That means you have to stretch your forefinger, central or middle finger, and the thumb of your left hand mutually perpendicular to each other. So let's say this is the forefinger, which gives the direction of the magnetic field, which is B, and this is the middle finger or the central finger, which gives the direction of the current. Then this thumb, when it gives the direction of the force, and all these are mutually perpendicular to each other. This is Fleming's left hand rule. A very useful rule to find the direction of the force. So this is Fleming's left hand rule. Okay, moving on to the next question.